we're going to look at average rate of change. So to start, we're going to look at this simple example. If a car travels 120 miles in 2 hours, its average rate of change or average speed that it's moving at would be 60 miles per hour. And this is logical because it travels 120 miles in 2 hours. So on average, roughly in each of those 2 hours, it's going half this distance, or 60 miles. So its speed or average rate of change is 60 miles an hour. In reality, it's going to go a little faster at times and a little slower at times, but that's its average rate of change. More generally, if y represents distance traveled and x represents time, then 2 points on the function y equals f of x are x1, y1 and x1, x2, y2. We could write that as x1, comma, f of x1 and x2, comma, f of x2. Then the average rate of change of the function y or f of x from x1 to x2 is given by f of x2 minus f of x1. That's the change in the y values or the change in the distance divided by the change in time, the number of hours or time that has elapsed. So the change in time between those two time values is x2 minus x1. And this is a form for average rate of change of the function f or y. For example, let's look at a realistic problem here. When a balance of $5,000 is owed on a credit card and interest is being charged at a rate of 14% per year, the total amount owed after t years is given by this function. So this is like our function y. What I want to do is compute this value, a of 3 minus a of 2 over 3 minus 2, and interpret what that means in terms of rates of change. So this is obviously an application of this, right? It's a change in two y values divided by a change in two x values. So this is average rate of change is, let's see, a of 3 would be, let's plug in 3 for t, so 5,000 times 1.14 cubed minus a of 2 is 5,000 times 1.14 squared all over 3 minus 2. So if we look at this, this is actually the balance after 3 years, and this value right here is the balance after 2 years. So when you subtract the balance after 3 years and the balance after 2 years, what you're looking at is the change in the balance after 1 year. So it's the change in the balance between years 2 and 3 actually. And it's divided by 1 because we're only looking at the change over 1 year here. So if we want to compute this number and get a value, what we'll do is we'll look at, we'll use the calculator here to do a little computation. It might help make this make a little bit more sense. So we're going to do 5,000 times 1.14 cubed, so to the power of 3, minus 5,000 times 1.14 squared. And if we do that, we get 909.72. So it's the average rate of change in the balance between years 2 and 3, or that's how much your balance grows when your interest rate is this much. It's essentially your interest that's charged in that 1 year. Okay, graphically, let's look at what's going on. The average rate of change of a function from x1 to x2, here's x1, here's x2. When you compute f of x2 minus f of x1, you're computing this change in the y values right here. And when you compute x2 minus x1, you're computing the change in the x values. So it's really the same as this y distance divided by this x distance, which happens to be the same as the slope of the secant line through those 2 points. So graphically, the average rate of change of a function from x1 to x2 is the same as the slope of the secant line secant meaning it goes through 2 points, through the 2 points x1 comma f of x1 and x2 comma f of x2.